My name is Vipul and I have 11 years of IT experience. During my IT experience, I have worked on multiple tools. So I started my journey from the Informatica data migration tool and then I moved on to the SAP world. In that I worked on SAP Data Services, which is again a data migration tool which is specific to SAP. And then I worked on SAP HANA 2.0 on-premise as well as SAP HANA on cloud. And after that, I worked on SAP Analytics Cloud, which is a reporting tool available by SAP. And it has a lot of great features available to us. And then after working in those technologies, I moved on to the Snowflake Data Warehouse and also MySQL. Apart from that, I'm also associated with Data Vision as a trainer for MySQL and Snowflake Data Warehouse. So let's get started. Welcome to the third day session of our Snowflake Data Warehouse course series. Until yesterday, we had discussed about the different layers we have within the Snowflake Data Warehouse. Here you can see that we had discussed the different decisions we have to make, right? So let us say if we just revise what we have discussed so far. So let us say you as a client, or maybe a client comes to you and he or she tells you that, okay, I want to implement a Snowflake Data Warehouse in our organization. And then you have to come up with a blueprint of how you will decide some parameters while implementing a Snowflake data warehouse. We had seen that how the different factors, such as the location of the client, the size of your database or data warehouse which you want to migrate depends on the many factors, right? They drive whatever different scenarios we have. Okay. So here you can see that we have to decide which cloud provider you want based on the feature. You want to decide on the region you want, and you also have to decide on the addition of this Snowflake data warehouse, right? Similarly, we had discussed that we have multiple layers within the Snowflake data warehouse. Um, we have a storage layer in which everything which we create in the Snowflake data warehouse is persisted. And then we had seen that we have two types of storage mechanisms. We have the capacity storage, just in case if we already know how much storage we need for our Snowflake data warehouse, and on demand storage types if we are not sure how much storage we actually need for our Snowflake data warehouse, right? We are not that much aware. And we had understood the different pricing model of different editions and based on different locations, right? So we will deep dive into this. We will also just understand what these credits are in today's section. Okay. Okay, so let's move forward to today's session. So before moving on to with the virtual warehouse, we just want to understand how the current architecture of your devices work, which will also help you understand how the Snowflake data warehouse also works right now. Okay, so if I consider this box to be the Snowflake data warehouse account, similarly, it will also have the same components which you have discussed yesterday. We have the storage layer, which is at the bottom. So these are all the diagrams which I'll be referring to again and again. Okay. So you have the storage layer, and then we have the compute layer. You can see it like this, compute over here, or you can paste it here as well. So this is your compute layer. And then finally, we have the cloud services layer, and so on. Okay. So this is how your Snowflake data was like. And now your Snowflake data warehouse account altogether is sitting on one of your cloud provider. Okay. Which we had discussed yesterday as well. So the cloud provider can be any of the major cloud providers. It could be AWS, it could be Azure, or it could be, I mean, your GCP as well. Okay. So it can be AWS, it can be GCP, it can be Azure. Okay, so it can be any one of them. Similarly, it can once you have decided on the cloud provider, you also have to decide on which region you want your Snowflake data warehouse account to be hosted on. Okay, okay. This we have seen. So now let's also see how your current devices work. Okay, if you say that this is your current system, this system can be your laptop, can be your desktop, can be even your phones as well, because we just want to see how our current systems work, right? So here you can see that if you look at your systems, it could be your laptops, for example. So it also has a storage layer, right? So it will also have a storage layer. This storage layer, you can say that it is your hard disk drive. So these hard disk drive are again of different types. Hard disk drive like HDD drives and so on, because they are also getting better and better with time. So you will have a drive, and these drives are actually available in our systems to persist the data. So let us say if you want to store something and you want to persist in your system, even if your system is shut down, or even if it is hibernated, or if it is rebooted, or if system crashes, you want some information to persist. You do not want it to be affected at all by the system shutdown. Okay. So that is why we have hard disk drive. In the hard disk drive, you have different drives. So you have like C drive, D drive, and so on. And if you talk about the Linux operating system, they also have different directories which have been created. Different partitions are also created in that sense. Okay. So let us say right now I am talking about a system where I have, let us say, 1 TB of hard disk drive, and I have, let's say, 200 MB here, 300 MB here, and the rest of the storage being allocated to it, right? Okay. And then this is how you will see that whenever you get a fresh installation or a new laptop, you will have a hard disk and it will have multiple drives. Based on your need, you can also go with one drive or you can go with multiple drives. Okay. So now, for instance, let us say I am having a game or an application. Let us say in this scenario, we have a game which I want to play on my system. Okay. So the very first thing which we have to do is that we have to install this game on our system. Okay, on our laptop. So now you will go to that website where that game is available and you download the installer files, or or you download the complete packaged installation file for that specific game. Okay. And then you will download it in your system, and then you will install that in your system, right? What installation actually does is that it places the execution files and the multiple DDL and DLL and multiple uh, what you can say, different files which are related to each other, which are dependent on each other, the environment variables, how the game should work, how much graphics it needs, how the processor will be worked. So all these different instructions will be contained within the multiple files. Okay. And once we install the file, once we install the game, all those files which are a part of this installation package, they will get stored in our drive. Okay. Let us say if you have installed something, if I go to my system, so here you can see that I have 3 drives. So this is the total storage I have within my system. Okay. So if I show here, I go to properties. Over here as well, you might find somewhere that I will have a specific storage. Okay. Where is that? So this is just a storage, and that's okay. We can check this later. And then here we have different option to see. Okay, if I go to storage, so here you can see that we have different storage informations. Okay. So total C drive is 236 GB. It is showing me only this C drive, and within that it is showing me different information. Okay. This is not showing me the total storage I have for the system. Okay, not a problem. So similarly, we can see that whenever we install something, so it will ask us where you want your files to be installed. So if I go to C drive, C users, you will have the users. Where is that? C users, users. So I'll go to user, which I'm logged in right now. And over here you have different folders. So here you can see that whatever I have installed, it is now available in a specific folder. Okay. So even if I go to C program files or C program files 86, x86, so here you can see that whatever apps have been installed on the system, they have been set up in a different its own specific folder. Within that, they have specific subfolders, and here you can see that multiple files have been generated by that application. So we have exe files, we have the XML files to have the uh, different information or different metrics about a specific system or a specific software. Okay. So here you can see that whenever I install something, that installation file will be stored in my storage system. Okay. So why it is actually stored in your storage system? Because this is a persisted data. Okay. So the data will be persisted no matter if you shut down your system, even if you reboot your system, all the information which is available here in your storage will persist. Okay. Similar thing also worked in Snowflake Data Warehouse. You have a storage layer. So whatever is stored, so in this sense, the storage will store the the table information, the user data, the metadata, and all these things will be here. You will have the stages information, you will have the stored procedure, function, and so on. Okay. So this way they will work similarly. Okay. So this storage layer is used as a persistence layer of your Snowflake data warehouse, which will store all the data in one place. Don't forget that in Snowflake Data Warehouse, we are mentioning something called as the data singularity, that only one version of a specific table will be available and it will be accessible by all the different users. Okay. We will revise these concepts again once we will go into the query execution. Okay. So now if we come back to the system, if I come to the system, so now let us say my game is now installed and I want to play the game. So if I want to play this game, so for that I cannot directly execute the different DDL files or different execution file directly in the storage. I need something called as CPU. Okay, so the CPU is the core component in this systems, which is responsible for processing the different information, right? So as per the name, central processing unit. So the CPU is responsible for taking the instructions and executing those instructions. Now the CPU cannot directly interact with the storage, with the hard disk which you have. So that is why, because if the CPU will take some file from here and then process it and try to write the backup data back there, the access speed of the storage is very slow. It will take a second to read something from here and will take a second to write it over here. So that is why the architects have invented something called as RAM, which is called as random access memory. Instead of directly interacting with the storage, the CPU interacts with RAM. So whatever instruction the CPU wants to process, it will bring that specific instructions from the storage into RAM. Okay, and then CPU will directly interact with RAM. So this is what you do if you want to run a game. Then those specific components which are required to run that game will be first of all brought from the storage into the RAM, and then CPU will fetch those instructions from the RAM, and then that CPU will execute those instructions. Okay. Now, if I talk about the different instructions, so you can say that different instructions or different programs, we have two types of instructions. We can have the deterministic instruction and the non-deterministic. Okay, deterministic. Okay. So in the deterministic instruction, the output is always the same no matter how many times you ask for the output. Okay. So if I say what is 2 plus 2? 2 plus 2 is always going to be 4. So if I ask the name of a person, if I have only one person record, so that value will always be the same. So let us say if I talk about the car of a color, the engine of a color, let's say if it is not has been changed or upgraded, then the value is always deterministic. The value can or the answer um, can always be very easily predictive as well. Okay, you can also say it like it is predictive. Okay. Whereas we have something called as non-deterministic. In non-deterministic, it is very difficult to judge the output of the certain scenarios. Let us say if a car is moving and I ask what is the speed right now, so the output is going to be different at different point in time because the car is not going at a specific speed or a constant speed all the time. So that is why the output of this question is going to be different all the time, right? So similarly, we have something called as deterministic instruction and non-deterministic instructions. Similarly, we also have deterministic functions, which always give the same output, no matter how many times I call it. And similarly, we have non-deterministic function, which provide the different outputs at different point in time. Okay. So now if the CPU is doing some processing and that process or that specific instruction is deterministic and you are calling that instruction again and again. So CPU can say that, okay, why am I calling that instruction again and again? Why I'm executing that instruction again and again if the output is going to be the same all the time? Why can't I store the result of a deterministic instruction in my storage, and whenever needed, I can directly take it out from here. Okay. So that is why the CPU comes with a specific and a special type of storage, which is called cache. Some will call it cache. So it's up to you how you want to call it, but the spelling will remain the same. So it's CHE. So here you have is that if a CPU is doing some operations and those operations are deterministic, so we have different criteria. Okay. So if the instruction is is deterministic, and the second point is that it is being executed again and again. Okay. Executed multiple times. So now in this case, the CPU will store the result of this information or this instruction in its cache. Because cache is stuck to the CPU, it is a part of that CPU, so that is why accessing that result is even faster than accessing the data in the RAM. Okay, so if someone asks you what is the hierarchy of accessibility, so cache is the first accessible. It is accessed in milliseconds or microseconds. Then RAM is accessed in milliseconds. It is microsecond, millisecond, and your storage, your persistent storage, your hard disk drive is accessed in seconds. Okay, so that is where you can see that with the advancement in technology, we are having a better and better CPUs. We are having better and better cache, RAM, and everything is also getting very cheap. So now, if I compare it to the Snowflake data warehouse, these three components, your CPU, cache, and RAM, belong to the compute layer. Okay, so these three components belong to the compute layer. So if you say the virtual warehouses in the Snowflake data warehouse, we have virtual warehouses. So the virtual warehouse is equivalent to this combination of CPU, cache, and RAM. Okay, because the virtual warehouses are responsible for taking the instructions and executing those instructions. So these are the components which a virtual warehouse consists of. So the virtual warehouse will consist of a processing power, will consist of its own cache, will consist of a RAM, which it will use to process the data. Okay. So this is one thing which you can very well see that even though we say that the cloud computing is a very new concept, but here you can see that you can very well easily compare it to your laptop as well. Okay. Because the general concept of how the hardware works is going to remain the same. Okay. The advantages which we have seen for this Snowflake data warehouse or any specific cloud-based technology is that now the data is very easily scalable, things are easy to use. We have low code, no code, or pro code options available. But apart from that, if you look at the hardware architecture level, the things are going to be very similar. Okay. So here you can see that we are able to kind of compare the your laptop with the Snowflake data warehouse architecture as well. Okay. Okay, one more thing which you want to see. So now we as a user, so let's forget this for now. So this is done. So now if I talk about the Snowflake data warehouse, so in the Snowflake data warehouse, you as a user, so I will do it like this. So this is your Snowflake data warehouse account, which is software as a service provided to you. So you can use this software uh, a Snowflake data warehouse. You do not have to install anything, and this box is readily available to you to do different operations. Okay, and then you as a user who is connecting through that specific system will have to use a browser, and using a browser only you will be able to connect to the Snowflake data warehouse. Okay. In the next section, we will see what all different ways we have to connect to Snowflake data warehouse. This is one way to connect to the Snowflake data warehouse. So you do not have to install anything. So I'll just remove it to just avoid any issues, avoid any confusion. Okay, so this is we are going to discuss right now. So you as a user will be sending different queries to the Snowflake data warehouse, and Snowflake data warehouse is responsible for different for executing that query. Okay, whichever you send. So if you remember, we had discussed about the cloud services layer operations. So why it is there? So it is responsible for the metadata management. It is responsible for the query optimization, and then it is responsible for you can say for the authentication and so on. There are a lot of different options, different roles which are done by the cloud services layer. Okay, let us understand what is this authentication. We understand that whatever user is logging in, that will be first of all checked whether that user is allowed to log in into this Snowflake data warehouse or not. All these checking will be done. And metadata, we will see later on what is metadata and what role is plays. Right now, we want to focus on the query optimization. Okay. So now let us say if I send any query to Snowflake Data Warehouse, let us say I say select star from instead of star. Okay. Select star from A in a left order join B on A dot 1 is equals to B dot 1. Okay. So now here you can see that instead of star, if I ask for the columns of table A only, then this is the something SQL query which I am sending to the Snowflake data warehouse. Because your Snowflake data warehouse is again an RDBMS, which stands for Relational Database Management System. So your uh, so whatever queries you are aware with, which support your SQL and SI standard, they will be applicable in Snowflake data warehouse. Okay. So here, what Snowflake Data Warehouse does is that it tries to optimize the query which you are sending to the Snowflake Data Warehouse. Okay, so let us say if I am sending this query, the Snowflake Data Warehouse will try to optimize this query to make sure that the query is in a better form and it also saves the time. Okay. One of the optimization which you can see is that there is something called as query pruning. Query pruning is also associated to this term. So the query pruning says that some of the operation which you are sending as a part of your query are being pruned. We will understand that later on as well. So this is just a just a reminder for you that we will do it later on. So there are some steps which are not required to be executed as a statement. They will be pruned or they will be dropped. Okay. So pruning meaning dropped. So certain operations will be dropped which seem unnecessary to the Snowflake data warehouse. So now let us say if I'm saying that I want to left to join table A with B, but I'm asking only the columns for A, table A, then in some specific scenarios, the Snowflake data warehouse will think, what is the use of doing this join if I'm not asking for the column for a specific table? In that case, it will try to optimize your query in a mathematical fashion. Uh, the optimization which are done by the Snowflake data warehouse will not affect the outcome, should not affect the outcome of the queries result. Okay. So it will make sure that even if some of the operation are deducted or removed from the query, still the output which is given by the Snowflake data warehouse, it should match. Okay. Okay. So now one more thing which you have to understand that each query which is submitted to the Snowflake data warehouse, it the Snowflake data warehouse creates something called as DAG. Okay. We have to understand like this. We have DAG, sorry, DAG. So the DAG stands for data, or sorry, it stands for directed acyclic graph. Okay. So whatever query you give to the Snowflake data warehouse, the Snowflake data warehouse will try to first of all optimize it. So the step one is optimize, op, what is that? Optimize. And the next step is to create a directed acyclic graph of query. How the directed acyclic graph looks for this query? So it will have something like this. So first of all, select data, select data from table A, and then the other thing it will have select data from table B, and then similarly once the data from table A and table B has been selected, and then we will do the join. So left outer join will be done between this table. So here you can see that if I this is one step, what's the second step? This is better now. So this is one step, this is second step, and this is third step. And your left auto join is dependent on the selection of data from A and B. So this is like this. And then finally, once the left auto join is done, then you are asking select you will say select the records or select the records from table table A. Okay, so this is how your query will look like. Okay, whenever a DAG is created, the DAGs are a very crucial part of Snowflake data warehouse, because every query which Snowflake data warehouse will have to run, that query will first of all be created into a DAG. Okay, so here you can see that. So a DAG has been created. Why it is called a DAG? Because it is always directed in the forward direction. It is non-acyclic in nature, right? It is acyclic, so that is why it is not going back in any direction. So it is always forward looking. line, and it is directed in nature. It from here, just looking by it, you can understand what is the direction. And here it is a graph which is formed in the Snowflake data warehouse. So this is something called as the query execution plan. Okay, execution plan. Okay. So here you can see that the Snowflake data warehouse will prepare an execution plan based on which your entire query will be executed within the Snowflake data warehouse. Okay. So here you can see that um, the query execution plan also comes with something called as the estimated runtime. Okay. Estimated execution time. Okay. So here you can see that the Snowflake data warehouse, when while it was creating a DAG for any specific condition or a specific query, it also provided an estimated time how much it will take to execute a set of instruction. So let us say to select data from table A, it will say that it will take zero point 0.1 seconds. To select the data from table B, it will take zero point 0.1 seconds. And to do the left to join, it might take zero point 0.2 seconds. It is a lot of time, but similarly, if you look at this Snowflake data warehouse, it takes somewhere between a milliseconds to do different operations, right? And then finally, it will take 0.01 seconds. Okay. So this way, this plan is created. This is query execution plan in which this Snowflake data warehouse will try to create a plan. It will create you can see that it will create a graph, which is called DAG, in which it will find out the different steps it will have to do, and then how much time it will take to run these multiple queries. Okay. So now once the DAG is created, this DAG is then submitted to the virtual warehouses. Okay. So once your query is optimized, once the query execution plan, so all these steps are a part of your cloud services layer. Okay. So whenever you send a query, so first of all, it will be optimized. Its query execution plan will be created, estimation time will be it will be generated, and then this query will be sent to the virtual warehouse. Okay. So this plan will be sent to the virtual warehouse. So based on these instructions, so you can say these DAGs are also, you can say that the query execution query instructions. So these are the instruction. You can say that it is giving an instruction to the virtual warehouse. Okay, first of all, take the data for this table, take the data for this table. You can do both of these operations parallelly because they are not dependent on each other. And then you can do the left to join. And finally, once the left to join is done, only then take the data from table A. Okay, so this is something which is submitted to the virtual warehouse. Okay. Now we have to understand the virtual warehouses. Okay, so virtual warehouses, which we have already seen, is a combination of different components. Virtual warehouse has its own processing. It has its own CPU. It has its own cache, and then it has its own RAM. Okay, so these are the components which are required to run any instructions which are provided to the virtual warehouses. So now the virtual warehouses come with different sizes. So if I show you this diagram, so if I go to the this one, maybe let me check. Okay, not this one. If I go to Snowflake and if I go here, okay. So here you can see that we have different sizes of the virtual warehouses. So the virtual warehouses here you can see that the virtual warehouse start with extra small, which is the smallest size of virtual warehouse, and then it keeps on increasing in size, extra small, then small, medium, large, extra large, and it goes all the way to 6s large. Okay. And here you can also see the credits which is consumed per hour for each and every virtual warehouse usage. So if you use this virtual warehouse, which is extra small, for 1 hour, if you give any instructions to the virtual warehouse extra small, and those instructions run for 1 hour or they take 1 hour to be executed in this virtual warehouse, then you will have to pay 1 credit. Okay. And similarly, for 1 hour of usage of the small size of virtual warehouse, you will have to pay 2 credits. Okay. This is here you can see that how the virtual warehouses are charged. Okay. So based on the usage, if you use for 1 hour, the 6x large virtual warehouses, then you will have to pay 512 credits. Okay. So if you remember, we had discussed yesterday is that we have different billing criteria. So if I go back over here, so let us say if I have gone with this North Virginia, so in this North Virginia, if I have the business critical edition, so if I just remove all this and let us say this is the case which I'm having. So I have the AWS cloud provider. Within that, I have the North Virginia region. And within that, I have created the business critical edition of the Snowflake data warehouse. Then 1 credit is equals to $4. Okay. So the question comes, if I want 100 credits within my Snowflake Data Warehouse account, in this case, because $4 will give me 1 credit, so I will have to put $400 into the Snowflake Data Warehouse account to get 100 credits. Okay. And now, based on how much credits I have, my Snowflake Data Warehouse virtual warehouses will be used. Okay. So here you can see that if I have different sizes, so here you can see that if I have the small size of virtual warehouse, then for an hour of its use, I will be credited. I will have a debit of 2 credits. Okay. And similarly, we also have credits per second. So here you can see that the different credits per second is also shown over here. So here you can see that we have this, if you want to get the per second billing, so you will have to divide this number, which is 1 divided by 60, and then again divided by 60, because this is per hour and this is per second. Or you can also divide this number by 3600. So if you want to get the per second billing. Okay. So here you can see the different billing information, and these are all the credits per second. And here you can see some additional notes. So the extra small is the default size of virtual warehouses. We will see that if we do not specify the size of the virtual warehouse, then by default, this is the size, and so on. This is the largest size of virtual warehouse area. Okay. So if you have a very complex scenario, if you have a very uh, compute extensive requirements from your software data warehouse account, then you can go for a larger size of virtual warehouses. Any questions?
So after crossing 10 minutes, it will be standard one for
It is all based on your virtual warehouse consumption. So if you talk about this one, so if you, I mean, it will be same as whatever is mentioned over here. So if you have the extra small, then it will be 1, and so on. It will be based on. Okay, just one
So
second.
So
my
Vipul,
question is here after crossing the
Ah,
10 minutes before slide you showed, you know.
ah, okay. This one.
So
Oh, sorry. This
this this is after every 10 minutes it will be rise like this, or it will be
one.
calculated
After every 10-60 seconds, it will be like that. So first, so if you go back to over here, from here you can ask a question. Okay. So this one, if you just stick to one. Yeah. Tell me.
Okay, here no issue. There in that
Oh,
slide,
okay.
after crossing
Uh-huh.
10 minutes,
Tell me.
10
10
minutes.
minutes. Oh, that is fine. I mean, 10 minutes corresponds to your how much? 600 seconds, right? So
uh,
if I just include one more row, so 10 minutes meaning that we have like 600 seconds, right? So for 600 seconds, the billing will be for 600 seconds. So for each second, it is, if you say, for each second, it is 0.0333. And then for, if I make it like into 600, so this is the billing uh, for 10 minutes. Okay. I don't know what it is. It should be, I have one second, 0. I think I have put less number of zeros. Oh, this is per second. I have to take this for 0.00056, and then I have to multiply it by 600. Then I will get the 0.336 is the billing for 10 minutes. Okay. 0.0336. Okay. Oh,
one more question
0.336.
here. The
Sure,
Excel
sure, sure.
and that sizes are there. No? So
Right.
which that we are going to as a I'm using based on the user, or it is based on the fixed.
That we will see. That we will see.
Okay.
So this is just a basic thing which we are seeing, the billing of these virtual warehouses. Let us see. Okay, we have different ways to see how much, what is the size of virtual warehouse we want. Let us also see that. Okay. Before that, is everyone comfortable? Everyone okay with that?
so Vipul,
Hmm.
this
Yes.
virtual warehouse, whether we this is just for the compute resource, the VM which Snowflake
Right.
giving you access.
This
So
part. Right.
uh, this credit is used only for that one. If we are running any other query, the cost is different, right?
This all is dependent on that. What type of query you are running in the
It is
virtual
like
warehouse?
just you logged into that virtual warehouse, which is a compute engine or virtual machine, which Snowflake giving, and 1 hour done, you are
Yeah.
taken that credit that much. But if you are running any further query in that, so that cost is different, right?
The cost is same. It all depends on how much processes you are giving to the virtual resources. Let us say if I have only one virtual warehouse of a specific size, right? So I will be giving multiple queries to my virtual warehouse to run. So let us say I give this query 10 times to the virtual warehouse. So the virtual warehouse will be executing this query multiple times, and how much time it took to execute all the different queries, that time we will have to get as the billing of the virtual warehouse. Okay. So if I say one, if I run, give, let us say if I give this query to the virtual warehouse, and this query will take 1 hour to execute. And then based on that, if I have the small size of virtual warehouse and a specific query has will complete in 1 hour, then I will have to pay 2 credits.
Okay.
Okay.
So even if I do not run any query and I kept open that virtual warehouse compute engine
No, no,
session
no.
for
In
one
that
hour,
case, no, no, no. If you are not giving your virtual warehouse anything to do, then there will be no billing.
okay,
Okay, you are because your virtual warehouse is not doing anything, it is just sitting idle, it is not doing anything. So in that case, your virtual warehouses will not be built at all. Okay, so this we have to remember because in this all belongs to the cloud terminologies. We have something called as pay per use model. So if you are using the virtual warehouse, then only you pay. If you are not using any virtual warehouses, if you are not giving any execution queries to your virtual warehouse, in that case, we do not pay at all. Okay. This
okay.
because we have all the cloud-based concepts applicable in virtual in the Snowflake data warehouse. Similarly, this pay per use is also applicable to that. So if we are not using it, we are not paying for it. Okay.
So this means I can log into virtual warehouse compute
No,
engine session. I can log in and kept it open. There will be
no,
no bill until I
no,
run
no,
the
no.
query.
Wait,
No.
wait, wait. We cannot directly interact with the virtual warehouses. First thing we have to say. Okay. We have this layer which directly interacts, which sends the query to the virtual warehouse. We as
Yeah.
user cannot, this is not like we have to create a compute engine and we have to start and it stop it. Okay. These all things happen automatically. We will see in the configuration of virtual warehouses.
Okay.
Whenever we send the query, only at that time the compute this virtual warehouse will start. And as soon
Okay.
as the query ends, the virtual warehouse will stop working.
Okay.
Okay.
Got
So your virtual warehouse will only work only during that duration. It has to do some processing. So let us say if I talk in that case, if I am having giving some operation to perform, as soon as this operation is done by the virtual warehouses, it will stop processing and it will again go back to the idle state. Okay, we can control all that.
it.
Only that duration in which your virtual warehouse was doing something, was doing some actions, or it was doing some manipulation, only during that time your virtual warehouse will be active. As soon as it will be done, it will go back to its sleep state or whatever you want to say, or in a wait state, and it will you will not be built. Okay, because if you are not doing something with that, you will not be built with up for that. Okay,
Okay. Got
okay,
it.
okay. So now we have seen that we have got different types of different sizes of virtual warehouses, and the question comes how do okay, which we have already received, how we can decide what size of virtual warehouse I should go with. For this, we will go with the architecture diagram based on which we can see that how much size of virtual warehouse we want. Okay, before that, we again have to make some decisions because this is where we started from. We have to make some decisions. So another decision which we have to make is that what is the size of virtual warehouse we want. Okay. Now, if I go here, then now I have to say, how do I decide for my company what is the size of virtual warehouse I want? So I have two questions to decide. So let us go back to decisions. Okay. So I have to make some decisions. What is so first of all, how many virtual warehouses want? How many virtual warehouse I want? And the second decision, and what size of virtual warehouse I have to go with. Okay. Okay. So now let us understand these two questions. Okay. So these two decisions we are going to decide based on our company, these two answers. Okay. We are looking for the answers. Now, before that, if I want to know the different sizes of virtual warehouse, first of all, I will have to decide to answer these two questions. I need to understand two things. Okay. So the first thing which I have to understand, what is the size of the team which is using my Snowflake data warehouse. Okay. The Snowflake data warehouse. So we are talking about the Snowflake data warehouse. Okay. And then one more thing which I have to understand is that what type of work what type of work will be uh, done by those users. Okay. Okay. So first of all, we have to understand what is the size of my team who are going to work in the Snowflake data warehouse. And the next thing which I have to understand, what is the type of work, whether they are doing very complex work, very simple works, and so on. Based on these two criteria, let us go with different permutation and combination. Okay. So let us say the very first case which I have. So I'll say case one. So in case one, I have less users, and let us say they are also doing simple work. Okay. So I am going with the four cases associated to these two statements. Let us say the size of team is very small, and the type of work which they are doing is also very less. Okay, this is case one. And if I say, if I create one more case, in this I will say the users are more, the more users, and simple work. Although the users are a lot in my organization, but they are doing some simple work. They are not sending a very complex query to my virtual warehouses. And the case three is like I have less users, but those users are doing very complex works. Less users and complex work. Okay. This is one case. And the last case number four will be more users and complex work. Okay. These are the, most used cases we'll have. So you might have one of these use cases. Okay. Or based on different departments. Okay. So first case is like you have very less number of users and the work which they are doing is very simple. Or it will be you have a lot of users, but they are doing very simple work. If you have case three, then in that case, you say that, okay, I have very less number of users, but the work they are doing is very complex. Or you can go for case four, where you can say that the users are more and the work which they are doing in the Snowflake data warehouse is also more. Okay. So now let us talk about different departments. Let us say you have the admin department. Okay, you say that the admin department is there and they belong to case one. I have, let us say, two people in my admin department and they are using simple work. They are not giving very complex queries to the Snowflake data warehouse, right? So I'll mention it here, the team name, the size of the team, and what type of virtual warehouse size I will have to associate to them. Okay. So I will say the admin team will, I have only two people who are going to be associated to the admin team, and they do not do very complex queries. They either look for a table, they create users, they remove users, they provide access to a specific table. So whatever work they are doing within the Snowflake data warehouse is not very complex in nature. Okay. And similarly, if I talk about another team where we have more number of users, so let us say if you take an example of I don't know, maybe they do not any other team. I don't know which example should I take for this team, and there will be more user and the work which they are doing is very simple. Okay. If I talk about the third team where the number of users are less, but they are doing very complex work. Okay. I can do the development team. So let us say I have three users in the development team, but they are doing very complex work because the development team will have to create very complex queries. They have to create procedures, function. They have to test it, and then you can say it as the more user simple work. Maybe you can take it test team. Okay.
Mm.
Yeah. So let us say in the test team, you have a test team where you can have a lot of users, but they are doing simple work. They are just testing some use cases. They have 10 use cases and they are just running the different processes and they are seeing that whether the output is right or not, or whatever things have been done by the development team. They are just doing very small testing. Okay. But we have a very large testing team. Okay. Maybe I have 7 members who are testing. And then I have case three for the development team where you can see the developers are very less, but they are doing very complex work. They are generating very complex procedures, functions, and so on. And finally, for case four, I can say that I have AI/ML team, okay, which is generating the machine learning, who are doing very complex work. We have a lot of AI/ML team. Okay, so let us say I have 5 members in AI/ML team, and those teams are working on a very complex work. Okay, so this case, I can first of all find out what all different teams I have. So it is better to segregate multiple set of users according to the work they are doing within this Snowflake data warehouse. Okay. And then once I have found out what size is applicable to a specific team, I can then decide what is the size of virtual warehouse I can go with. Okay. So if I go with the different sizes of virtual warehouse, here I can see that I have these two options. Okay. So let us say if I have the if I go for case one, where the less number of user and work is simple, then I can simply give them the extra small virtual warehouse. Okay. So I do not have to give a very complex size of virtual warehouse. Okay. I will give them extra small virtual warehouse. And then for the case two, where the number of users are very more, I mean, we have a lot of users, but the work they are doing is again simple. So I can either go with extra small or I can go with a small virtual warehouse as well. Okay. So I will say I will go with a small size of virtual warehouse. And then in the third case, we have a less number of users, but they are doing complex work. In that case, I will give them a more capable, maybe large size of virtual warehouse. Okay. I will say because you are doing a lot of manipulation, the user are very more. So I will give you a stronger virtual warehouse. And similarly, if I go for case four, then in this case, what I have to do is that I have to assign an even more stronger virtual warehouse because these users are going for even more strong queries. Okay. So maybe I will go with 2x large. Okay. I will give them 2x large virtual warehouse. Okay. So this way you will have to decide, first of all, you will have to group multiple people in a specific category based on the type of queries they are doing, what is their role, and then what type of queries they are doing. And then based on that, you will have to decide which size of virtual warehouse is good for them. So now these decisions, I can make it very clearly. So if I go back to the questions, how many virtual warehouses I want? So in this case, in your company, you might go with 10 virtual warehouses, 15 virtual warehouses, or 2 virtual warehouses, though there is no limit of how many virtual warehouse you can create or you want to create. Okay. We are not restricted with that. Okay. So now how much virtual warehouse I want in this case? I need 4 virtual warehouses. And what sizes of virtual warehouse I want to go with? I want to go with these type of virtual warehouses. Again, if you are going with a real case scenario, I can have any size of virtual warehouses, any number of virtual warehouses. I can also have the same size of virtual warehouses in my system. Okay. This is one Snowflake data warehouse account. Okay. So what I'm saying is that if this is your Snowflake data warehouse account, okay. So if this is Snowflake data warehouse account, okay, or I can also take that this over here, I can say that I need 4 virtual warehouses. If I break it down again into 2 parts, if this is your compute layer, and then if you have the storage layer is the one which which will be there. Let us say in storage layer we have got 10 TB of storage. Okay. And then finally it is sitting on the AWS, let's say AWS, North Virginia, and the Snowflake data warehouse account we have, it belongs to the business critical. Okay, this all things we have seen. Okay, this is a decision which we have already made. This decision we made, this decision we made in the previous session, this one as well, and this one as well. So in this case, today in this section, we are we are also comfortable that we have 4 teams. We have the admin team, we have the test team, we have the dev team, and finally we have the AML team. Okay, or I can also say ML team. Okay, and then each of these team is associated to a virtual warehouse. Okay, so we have the so I can also give a name to the virtual warehouses. Okay, to know that which virtual warehouse is assigned to which team. I can also have a dedicated name to the virtual warehouses. Within a single Snowflake data warehouse account, we should have unique name to each and every virtual warehouse. I can give a name admin slash admin underscore virtual warehouse to this virtual warehouse name. So this is the name of virtual warehouse. Okay. Name of virtual warehouse. Okay. So we have an option. We have a possibility. We have an option privilege to define the name, unique name to each and every virtual warehouse. I will say that this is admin underscore warehouse. This is test underscore virtual warehouse, so that you can come to know which virtual warehouse is assigned to which team. So this is helpful over there. Is virtual warehouse is a cloud-based concept or a physical one? It is on cloud. Okay. So we do not, we will see that how we can actually create a virtual warehouse. These are all based on the cloud. Okay, we did nothing is in the on-premise. Okay, so if I talk about the Snowflake data warehouse, the Snowflake data warehouse is a software as a solution, and it is all applicable available to us in the cloud. Okay, there is no component which is available on-premise. For AWS, maybe I mean it is existing somewhere for the organization. For Snowflake data warehouses is on-prem. For us as a user, is it on cloud? Okay, because it has to exist somewhere, right? So for Snowflake data warehouse, yes, it is on premise because they are hosting it somewhere. They are taking care of that. They are maintaining and managing everything. But as a user, as a client, this is a cloud-based solution because we do not have to manage it. Okay, so for different people it is different type of solution. Okay, because for us we do not have to manage, we do not have to take care of that, we do not have to see the optimization, we do not have to see where the storage is done, where the metadata is stored, where everything is happening, how the query is being executed, where it is executed. So everything is out of picture. So for us it is a cloud based solution. Okay, is it all okay? Swati?
Yes, sir.
Yeah,
Yes, you.
okay, thank you. Okay. You can call me people. No, I mean, that's fine. Okay. So everyone, because I don't know whether it belongs to your organization or not, but as soon as we enter the corporates, we are we are actually told to take names and I don't know. It's up to you. Okay. So as soon as I entered, when I was in college and I came to the corporate for the very first time, so the very first lesson which they told me is that you have to call us by names. So okay, I mean every different organization have their own rules, so that's fine if you want to go with. So that is fine. Okay. So so first of all we have found out different departments, and then we have found out different virtual warehouses. So admin underscore virtual warehouse will be assigned to them, and then dev underscore virtual warehouse. I have not mentioned it here. So first of all, let me mention it here. Dev underscore virtual warehouse, and then ML underscore virtual warehouse. Okay. So this is test underscore virtual warehouse, ML underscore virtual warehouse. Okay. Virtual warehouse. Okay. So now this is what we have done. And then we have also finalized the sizes of the virtual warehouse. If I mention it here, so this is admin one is extra small. Oh, I took small, I guess. I wanted to take, okay, this is extra small. And then we have the development with the large size of virtual warehouse. The ML team is going with 2x large, 2x large. And then finally, your test team is going with the large size of virtual warehouse. Okay. Okay, so now this is the blueprint which we have created based on different decisions we wanted to make. So this is where we started from. We had a budget. We want to know what all features we want to use, how many employees and type of workload, what is the location for my Snowflake data warehouse account. So now we are ready with the blueprint to show the client that this is the type of architecture we are going to have within our organization when we are going with the Snowflake data warehouse. Okay, this is one Snowflake data warehouse account. Just I am repeating it again and again because we have to remember that we are referring to a single Snowflake data warehouse account. We are not just going into multiple Snowflake data warehouse account. So right now we are just talking about all the different artifacts within a single Snowflake data warehouse account. So now we can run, so the different people will have a role associated to it. So let us understand that as well. Okay. So now we have a concept called as privileges. Okay. So first of all, whenever someone wants to access the Snowflake data warehouse, here you can see that we have in total, if I just do the summation, how many members I have. So I have 17 members in my Snowflake data warehouse team. Okay. So now for each member, for each user I have to associate that user with a specific role. Okay. So now we do have some inbuilt role as well. We can also create some custom roles as well. Okay. So these roles are also containing something called as privileges. So privileges decide what kind of activities you can do within your Snowflake data warehouse account. Okay. So if I talk about the admin team, so the admin team should have complete privileges. They should be able to create user, delete user, assign them some roles, revoke the roles as well, to delete a table, to delete a view, to create a table, to create a view. I want the administrator to have the complete control. Okay. So based on that, whenever a user joins my Snowflake Data Warehouse team, I have to associate a role to them. Okay, we will see that later on how we can have a role associated. Okay, this is where we have a concept called as RBAC, which is a role-based access control. Okay, okay. This RBAC, which is role-based access control, decides what access that person has based on a specific role. So this RBAC's admin will say that this administrator can do anything within Snowflake Data Warehouse. This test team will tell they cannot create an object, they cannot delete an object, they can just run some queries against some specific tables or against some specific databases, right? Development team should have access to create tables, create procedure, delete procedures, um, even create roles or delete roles as well, because they want to see how the data tables will be shown in the backend. AML table, again, they should be able to create tables, delete tables, create models, access the if you are using some external AML tool, so these users should be able to connect to that to create their models and so on. They should have hi Malik. Okay, that's right. So this is how we can associate a role or different set of privileges to a specific user based on whatever they want to do within this Snowflake database. Okay. This term you will hear a lot. So we have something called as RBAC. Okay. So this thing of RBAC based. Okay. So this is what we have to see. This we will also see in the future lectures. So again, what you have done is that you have segregated multiple set of user in a specific role, and then based on that role, you are assigning a virtual warehouse. So a specific team, so let us say if you are in a specific admin team, you can only use the extra small, this admin underscore virtual warehouse. If you're in the test team, you are using the test underscore virtual warehouse. So what I am doing is that based on the role, I am saying that if you belong to the admin role, you can only use the admin virtual warehouse. You cannot see other virtual warehouse. You cannot even use that. I can allow you, but right now by default, the person who belongs to admin team can only use the admin virtual warehouse. If a person belongs to the test team, they can only use test virtual warehouse. At the test dev team, we can only use this one and so on for the other team member as well. Okay. So this way it will always also help me to segregate the kind of work which they are doing. Okay. So now here I am done the segregation based on which team, which members can use which virtual warehouse. So that if I'm using the virtual warehouse dedicated to a team, these virtual warehouse will not be interacting with each other. So we will discuss that as well. So this is what we have done is that we will have different users. They will be assigned to a specific team, and that team can only work with a specific virtual warehouse, and that virtual warehouse will be doing that load, and then billing will be done based on what virtual warehouse is have. Okay. So if I mention the credits per hour, then I can say if the admin team, the maximum billing which I can take is that this is credits per hour. Okay. So here, if I talk about the extra small, so extra small is going to have the 1 credit per hour. The small size is for 2 credits per hour. It is going to the end. And then if I talk about the large size of virtual warehouse, the large one is 8 credits per hour. And finally, if I talk about the 2x large, so the 2x large is 32. Oh my God, that's a lot. Okay. So this is the answers we have for our client. We have prepared the blueprint. This is the blueprint which the client really wanted to have. He is having the multiple questions answered. So we know that how many virtual warehouse we need, what is the size of virtual warehouse, what the billing will be. So if he thinks that this billing is a lot, he can say, okay, I do not want to give this much billing. Let us reduce the 2x large to x large or whatever. If he thinks that this is less, he can also go with 3x large. Okay. So he knows how much storage I want, how many virtual warehouses I want, how many users I am having, what all roles I have to associate with them. I mean, the roles will have a lot. So right now we have not gone into the storage layer. We have not understood how we can actually create table. So all your tables, your views, your views, your users, all the metadata, all the different what you can say, everything which you create, the stage object, the procedures, the functions, and so on, everything will be created in this storage layer, which we have seen already as well. Okay. So if I go back over here, so now we are done with this. So now tomorrow, what we will do is that we will see how we can actually create a virtual warehouses. Okay. Any questions till now? So are you getting it? Are you enjoying it? Because this, see, enjoying this session is also very important. I should also enjoy it. You should also enjoy. Okay. This is not a boring lecture. This is a very interesting technology. So I just want you to really understand what is going on. So if you have any questions, please let me know.
So Vipul, like for
Yes, Brajesh.
uh, a small admin team, two people using
Ah,
a
extra
small
small.
warehouse, extra
Ah,
small. So if both log in at the same time, they will
mhm.
use
Yeah.
two virtual machines differently, like virtual warehouse,
We
or
can send any query, any number of queries to the virtual warehouse. We will see that in date by. So if we can give 10 queries to a same virtual warehouse, to multiple people can use the same virtual warehouse at the same time. It is not like,
but
um,
each will
yeah.
have a different login, right?
Oh, yes, 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 yes. Each user will have a different login. They can use a specific virtual warehouse. They can run multiple queries to the virtual warehouse. Okay, so there is a segregation as well, right? The virtual warehouse will not mess up multiple queries. So it has something called as concurrency. It can run
Yeah.
multiple queries.
Okay, but like in ML, AI ML, five people are there and they are using expensive
Huh.
virtual warehouse. So if
Uh-huh.
each one is login, currently
Mhm.
like all five logged in,
Correct.
so they will use a separate virtual warehouse each time,
Mhm. No,
or
no,
it
no,
is
no, no.
something like
Same,
shared.
same. Shared architecture. We do have a shared architecture within that. So the virtual warehouse. So let us
Okay,
say if multiple queries are coming to your same virtual warehouse, instead of this is if two queries are coming from the user, so the virtual warehouse will know about the context of the query, who is actually asking for that query. So based on that, it will return that specific result to that specific user. So it is capable of running multiple queries, and it is also context aware. It knows about who is asking for that query so that it can reply back to that result to that specific user.
okay.
Okay.
It means like
So
a virtual warehouse, we can assign a group of people. They will use the same
ah,
resource
yeah,
and
yeah, yeah.
whatever run. Okay.
Yes, yes, yes. We can have concurrency within that. We will see that. Okay. So it is not a problem. We can have multiple, we can even have 20 people. We do have a mechanism within virtual warehouse where we will decide how much load a specific virtual warehouse can take, whether it can go with concurrency or not, and so on. These all controls we can do while creating a virtual warehouse. We will see that. Okay.
Okay.
So this
Anyway,
will not.
thank you so much. Yes. Yeah.
Yeah. Hi, people. This will
Sorry,
not change.
sorry. Can you tell your name? I can't see your name. It is Windows 11.
Sorry, I want to change, but I'm not able to say. This is Kumar.
Yeah, hi, Kumar.
Yeah. This is here. All this is taken care by the admin, single
Mhm.
admin. Na? So there is no involvement of the all the users. No? For this
Oh, no,
specific.
no, no, no. This architecture, you might have an architecture team, maybe admin team who is designing everything, who is creating everything, and they do not have to interact it again. Once your system is in place, you do not need to reorganize everything. Maybe after 6 months or maybe every year, you will revise everything whether the system is working fine, and then you can do tweaks to your system. You can add one more virtual warehouse, and everything will be done by a specific admin team, or you can have a specific team which is just taking care of the architecture. You can have an architecture team.
Okay. One more question regarding the
Ah,
last this one.
yes, yes.
Regarding the users, so
Mhm.
they will give the for the group of users for the single user, or how it is like what is it like SSO? I heard something that SSO.
Sorry, sorry, sorry.
So here group of people they will give
Ah,
you single user like a SSO. What exactly that SSO? I heard somewhere saw somewhere
where
SSO.
is that? SSO. Oh, SSO is single sign-on. Okay. That
Okay.
is something which is used to log in into your Snowflake data warehouse. Okay. So what you will do is that we do have something called as, so right now, if I go back to the on-premise system, so have you attended this session?
First day no, second day I attended.
Okay. Okay, no issues. So maybe if you will go through this, so right now here we have a firewall. So we are protecting whatever users can log into that system of if I talk about simply. Okay. So let us say if you have an organization, in that an organization you have multiple users. Okay. So let us say your organization is using something called as login, different login. Okay, there are a lot. Okay, so if you're talking about the Windows, they have their own. Windows have Kerberos, I guess. Okay,
Mhm.
so this SSO will actually help you to log into your Snowflake data warehouse. Okay, so SSO, you do have the inbuilt within the Snowflake data warehouse, or you can use SSO. So within your organization, you have different users and you have a role associated to all the users. Okay. Then now what you want to do is that you want to import all these details for a different users and role within your Snowflake data warehouse. In that case, you can use SSO. We will see that in depth that okay, how the SSO works by the way. Okay. So using SSO, you can log into the Snowflake data warehouse. Okay. This SSO will actually direct what role a specific user will have to log into the Snowflake data warehouse. So instead of logging directly in the Snowflake data warehouse, so if I show you right now, okay, I will just close it. So if I show you the Snowflake data warehouse, okay, so if
Uh,
I hopefully it will not log in. One second.
Vipul, is it like SSO means the role is login into that account instead of user?
Ah,
Means,
I'll show you. So here you can see that for the first time, whenever I'm logging into the Snowflake data warehouse, it is showing me this page. Okay. So you have to provide the username and password. So these username and passwords are first of all have to be created within your Snowflake data warehouse. Okay. So all these users and passwords, these all details are created within your Snowflake data warehouse. And as soon as you go to the home page of Snowflake data warehouse, you have to provide your username and password, right? Similarly, you can also configure something called as SSO, where you will not have to provide the username and password in your Snowflake data warehouse home page, whereas you will have to log in into some other portal of the SSO portal. Whenever you go to the home page of Snowflake data warehouse, you will, instead of being directed to this one, where is that? Instead of directing you to this one, it will direct you to this SSO page. So you will log in here. Then based on that, your credential will be validated, and then you will go to this Snowflake data warehouse. This step is completely eradicated. You are not presented with this page. Okay. So you will log in into some other portal, and based on that, then the authentication will happen here. Your username and role will be associated to that, and then you can go into this Snowflake. We will see that in depth. Okay, don't worry. So this is something we do have a different portal where you will log in, and this SSO will give something called as SAML assertion. So this SAML assertion will actually contain what type of different role we have within the Snowflake database. Okay. So this is so if you talk about Snowflake data warehouse, we do have SAML 2.0 compatibility. Anything less than that is not applicable. Okay. So you have to integrate any other SSO which is SAML 2.0 compliant to use that. Okay. So I don't want to go into the details to confuse others.
Okay.
So if I hope you have understood this, if you are aware of this SSO.
Okay. So if I give that link, we can log in anyone, na?
Uh, yeah. You can log in anyone until unless you have you have to maintain this users and role somewhere else. So if you have this user and role in your on-premise system and you want to use that, you do not want to create your user and role again in the Snowflake data warehouse. You can configure SSO within Snowflake data warehouse, and then you can reuse the same roles and users within SSO to log in into the Snowflake data warehouse.
Okay.
Okay. You do not have to create all these users and role again in the Snowflake data warehouse. So that is how you will use SSO to log in there. Okay.
Great. Thank you.
Okay. No issues. Anyone else? Any questions?
Yeah,
Yes, Ravi.
Vipul. Can one user be assigned to two teams?
Yes. A
Uh,
person can, this is all roles. So a person
uh,
can belong to the admin team, can belong to dev team as well. Yes, possible.
okay.
Okay.
Vipul,
Yes, Deepnand. Oh, yes,
whatever
Harsha.
you're telling,
Sorry.
yeah, whatever you're telling about that SSO login, in
Mhm.
that you told that we don't need to create all the time user for every time, right?
Yeah. In
So
the
it
Snowflake
does,
data warehouse.
yeah, in Snowflake data warehouse. Does it mean that we are just giving grant of mm, means we are creating just functional roles, and we are providing access roles to those
Right.
functional roles, and with the help of those functional roles, we are logging into the through SSO in
Exactly.
data warehouse.
Exactly. So if you had an organization and in this organization you have multiple users, let us say if you had a user A, B, C, D, E, F, and then you had different roles associated to that. Let us say you had an admin role here, you had the development role over here, and then in the SAML assertion, you will have to associate that the admin team which you have over here is equivalent to account admin. So you will have to say admin is equal to account admin. And this is how you can map the different roles on your different uh, on-premise system to the Snowflake data warehouse roles. Okay. Account admin, and one second, I am going with the wrong words, account admin. And then you will say that if the user DF is coming, then in the SAML assertion, you will say that DE is equals to dev role within the Snowflake data warehouse. So this is how you will have to map which role that person has to have, because the role over here in the on-premise will be different from the roles we are defining within the Snowflake data warehouse. So in the SAML assertion, you will have to say, okay, this user is there. If admin is coming, it means that the account admin role, it will be mapped to the account admin role within the Snowflake data warehouse. So based on that, that user will be associated to a specific role within the Snowflake data warehouse, and that person can do whatever activities they can do based on their roles. So all these things are defined within the SAML assertions, and they
Okay,
should be SAML 2.0 compliant.
got it. Yeah. And one more question
Mhm.
regarding the billing
Okay.
of the uh, as you said that for first 60 seconds
Mm.
everything will be charged as for 1 minute, right?
Right, right, right. Minimum billing.
So if we are executing 10 select queries also, and they are taking like 40 seconds or something, still
Okay.
they will charge for 1 minute, right?
Yeah, yeah, yeah. No matter how
And
many processes are there, it is based on the usage, the time for which you
yeah,
are using that.
yeah, collectively it is suppose it is taking 40 seconds, then also it will
Mhm.
charge us for one query
For
only,
one
right?
minute. Right, right.
Oh, sorry,
For
1 minute.
1 minute.
Yeah,
1 minute.
yeah.
Yes.
And the moment it goes to 61st second, then after that it will
Per
for
second.
example, yeah, for example, the next query is for it is executing for 1 second
Mhm.
only. The bill will be
Oh,
charged for 1 second.
it will be for 1 second, right? It is for the first 60 seconds that minimum billing is 1 minute.
Yeah, though you are querying a lot of queries also, which is
No issues. It is based
executing.
on the execution time. Yeah,
Yes, yes. Okay, thank you.
that's great. Thank you. Any questions? Oh, we have a, okay. Yes, Kumar. Okay.
Here,
Kumar.
that
Ah.
sizes are there, na, that we can,
Mm.
so while executing, we can change it, or it is fixed.
While executing, no, but yes, we can change the size of virtual warehouses while it is executing. Even if you change the, if you want, you can change the virtual warehouse size while executing. But whatever query is executing, it will be executing on the old size. But yes, we can change the virtual warehouse size as well. Good question. If let us say tomorrow, let us say 3 members are added to the admin team. If I add one more person and I think that extra small is not good, I can change it to small size as well. Okay. So I can change the size of virtual warehouses based on the need. Okay. That is good question. Thank you so much. So yeah, I can change the virtual warehouses later on as well based on the demand.
Uh,
Not while the execution of the query, that is not preferred.
mhm.
But yeah, yeah, you should change it when the query is not there. And one more good thing about the virtual warehouse is that even you do not have to put your system down. Okay. So when you are changing the size of virtual warehouse, you do not have to say, okay, nobody is going to send any queries. I am going to increase it. Parallelly, the person, whenever they are sending queries, they can also execute the queries. Okay. But let us say if I am sending a query and the person is changing the size, if my query has already been submitted to the virtual warehouse, it will take the older size of the virtual warehouse. Okay. But after the change of the size, whatever query will come, they will correspond to the new size of the virtual warehouse. Okay. I hope you are getting it. Okay.
What
Anyone
if
else?
limit? Yeah, this is one.
Yes,
What
Swati.
if if limit exceeds? Means the query is processing a lot. It need more
Mhm.
process. XML is not enough at that time. But yeah, is
Yeah,
it
we do have
one more XML is added, or what will happen?
a feature for that within the creation of software data warehouse. We will see that. Okay. How we can have different instances within a virtual warehouse. Within a virtual warehouse, we can create multiple instances based on the load as well. We do have that as well.
Okay.
We will discuss that tomorrow. Okay.
Yeah,
Thank you.
sure.
Okay. Anyone else? Oh, because that is going to take time. That is why I'm not covering it right now. So yeah, small questions I can take right now. Okay, but something which we are going to discuss tomorrow, which is going to take time. We will surely discuss this tomorrow. Okay. Okay. All good. I hope you enjoyed today's session. Sorry. Happy Gandhi Jayanti to all, and we will meet tomorrow. Oh yes, yes, Dipnar.
No,
Okay, you
nothing.
are on.
We will. I'm good.
Okay. Okay. Okay, then thank you so much. We will the one thing which I did incorrectly today is that I started recording late. So you might not be able to see all the video being recorded for the day. I'm sorry for that. I came to know about it later on. So you might see a recording being started a little late. So sorry for that. If you want to revise something, so you will have to go to the PPT and the recording will be there for, let's say, for the last for 40 minutes. I forgot to record this session. I'm really sorry for that because some changes are there in the portal and I am still learning that. I put the recording on hold in the beginning and I forgot that. So sorry for that. Okay. So if you think that something is missing, if you have any questions, please do let me know. I can repeat it in the next section. Okay. Okay, then have a great day. Have a good time. Have a nice day. I guess it will be off for many people. So I hope you will get time to revise this concept as well. Okay, then I will close the session and we will meet tomorrow.